Welcome back to part 2 of P3. This part covers the scientific notation portion of the unit. Okay, so P3, part 2. Okay, so scientific notation. So we pretty much use this to represent very large numbers or very small numbers, and in the scientific community they deal with a lot of big numbers and very small numbers, especially when dealing with like distances to planets or stars or the mass of an atom, things like that. Okay. All right, so scientific notation, what is it? So X is in scientific notation if written as some number a times 10 to the n, where two things. Number one, this a number that we're talking about here is some number that is somewhere that a number that is greater than or equal to 1, but it is less than 10. Okay, so it has to be more than 1. So it can't be like 0.9. It has to be more than 1. Okay, so it could be 1. It can be 1.1. Okay, but it has to be less than 10. Okay, and then the exponent, n, is an integer. So that means no fractions or decimals. Okay, so your exponent is like 0 plus or minus 1, plus or minus 2, plus or minus 3. Okay, no fractions or decimals. All right, so for example, we might have something like this. So this number is a very large number, and this one here represents the distance in kilometers to a sun or a star. I think it's a star. Okay, so let's see, 1, 2, 3, 4. Okay. And here, so if you're writing a paper and this distance keeps popping up in your paper, it can be tiresome to have to write this number over and over again. And so another way to write this is by using scientific notation, which would be 4 times 10 to the 13th power. Okay, so same thing with this here number, which is the mass of the hydrogen atom. And so it looks like this. So I have the 0 point, and so you don't have to pause the screen and count how many zeros I'm going to be writing over here. I'll be writing 23 zeros after the decimal point. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay. And then 1, 6, 6. Okay. So, I mean, just by writing just this one number here and having to write those 23 zeros after the decimal point, you can see how exhausting that would be if you had to write this number over and over again in a paper where you're talking about the mass of the hydrogen atom. So this is so much nicer. 1.66 times 10 to the negative 24. So much easier. Okay. All right, so just kind of note here that the exponent represents the number of places the decimal moves. Okay, so The exponent represents the number of places and the direction, actually, and the direction the decimal moves. Okay, so we can see here, let's compare these two numbers that we wrote up here. So we can see here, this number, this is a very large number. Okay, we see here, this is a very large number. This is a number that's greater than 1. Okay, so if this is a number that's greater than 1, then we will be dealing with positive exponents. But you'll see here, this is a number that's less than 1. So the numbers that are less than 1 are going to be using a negative exponent. Okay. And then over here, we originally set up here that this number here that's being multiplied by this power of 10, this number a, has to be a number that's somewhere between 1 and 10. Okay, so clearly this is not a number between 1 and 10, right? And so what happens is the decimal is originally over here. And what happens is we have to move the decimal to get this big number to be small enough to be a number that's between 1 and 10. So you keep moving it along. That's still not a number that's smaller than 10, right? And this is getting closer. Keep moving that decimal. If you put it here, that's the number 40, which is much smaller than this huge number. But 40 is still not a number less than 10. So if I move it one more time, now I get the number 4. And 4 is a number less than 10. If I move it over one more time, I get 0.4. And now that's a number smaller than 1. But we want a number that's somewhere that is greater than 1, but smaller than 10. Greater than or equal to 1. Okay, so that means that that would have to go right here. 40 is too big. 0.4 is too small, but 4 is perfect. So the decimal would have to go right here in order for us to get that 4. And so we count to see how many times the decimal has to move. So if the original decimal point is right here and it moves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then one more, 13. So we see here it's positive 13. Okay. And remember, it's these numbers that are greater than 1, and this is like quite a bit larger than 1. We'll use positive numbers, positive exponents. Okay, so here, on the other hand, this here is a number that is less than 1. And so when we rewrite it, it will use a negative exponent. And again, we want this number to be a number that's between 1 and 10. So if we move this decimal all the way to here, if I move it just to here, 0.166, that's still too small. If I move it here, I get 1.66, and that's a number that's between 1 and 10. Okay. If I move it here, that's too big because that's 16.6, and we want a number that's less than 10. Okay, so that would have to be right here. So we would get 1.66, and then you just count how many times you move the decimal. We already know this is 23 zeros, and then one more time, move it one more time, and that'll give us the negative 24. Okay. All right, so go ahead and give this a try. Go ahead and see if you can write each of these in scientific notation. They won't be quite as large or quite as small. So write each in scientific notation. Okay, so go ahead and try this one. 56,920. And try this one. 0.000093. Okay, so go ahead and hit the pause button and come right back. Okay, so over here, this first number. Okay, so this first number here is a number that's greater than 1, so it's going to have the positive exponent. So we have here 5.692 is where I need to place the decimal. And I see here that it moved 1, 2, 3, 4 times. Okay. And this one, I see the decimal needs to be between the 9 and the 3, so that's 9.3. And this here is a number that's less than 1, so my exponent is going to be negative. And it moved 1, 2, 3, 4, 5 times. Okay. Excellent. And go ahead and try these. Let's see if you can go the other direction. Go ahead and write each in decimal notation. Okay, so try this one. 6.97 times 10 to the 9th. And try this one. 4.6271 times 10 to the negative 6. Okay, go ahead and hit the pause button and come right back. Okay, so 6.97 needs to move over 9 times. So 1, 2, and so I need 7 zeros. 1, 2, 3, 4, 5, 6, 7, giving us a total of 9 places that the decimal has moved. Okay, if you want to do this, that's fine. You don't have to. All right, so this one, negative 6. So this needs to become a number that's very, very small. So I need to, here, 4, 6, 2, 7, 1. It moves over once, so I need 5 zeros. 1, 2, 3, 4, 5. Okay, because it was originally right here, and it needs to move 6 times. Moving on the other side of the 4 counts as 1, and then I need these 5 more zeros. Okay. All right, excellent. So your homework, again, don't forget, it's not going to be on WebAssign homework list. The Chapter P homework is going to be optional. Definitely focus on the topics that you are unsure of or need some review on. You don't have to do all of the problems I assign, especially if I assign 5 through 103 odds. Still a lot of problems, but you can do them if you have the time. But definitely focus on the section of problems that that you are having trouble with. Okay, maybe just try a few from the other sections just to make sure you have it down. Make sure you can get it done. But focus on some of the other areas that you don't remember learning, or you remember learning it, but you forgot how to do it. Okay, and don't forget the Chapter P assignments are going to be out of the book. So if you have the book, great. If not, it's okay. You have the electronic version of the book. You can just go to your Cengage WebAssign and access the ebook, and then just go to the P3, section P3. It works just like a book. It has a table of contents, and you can just click on the table of contents. You can click on chapter P, and then when you click on that, it'll give you all the sections P1 through P8, and just click on P3 and it'll take you there. And then it'll show you all of the examples, the notes and everything. And then you can just start on your homework, it should be on page 23 in the book, whether it's the hard copy book or the electronic version. It's on page 23, and you can work on numbers 11 through 37 odd. And this is kind of nice too, because answer the answer key, if you remember back in the day, or if you have the hard copy textbook, the answers to the odds were always in the back of the book. And here, since it's an electronic version of the book, the answers are right there next to the odd problems. You can just click on the answer and it'll reveal it to you. Okay. All right, so that concludes section P3. Again, if you have any questions, feel free to email me or text me. I definitely get back to you quicker if you text me. I'll see you next time.